Hi, I'm Don Viviani, Professor of Oceanography at Leeward Community College. Welcome to this training video for the University of Hawaii System Red Hill Task Force. This is a refresher video for those of you that have already had in-person training. The idea here is that when you're going out to the community to collect tap water samples, you have a refresher so that you sort of remember how to collect the samples that you're going to be collecting. Today I'm going to go over the collection of 5 different types of samples. The first type of sample is our samples for non-purgeable organic carbon, NPOC. These are collected in a 40 milliliter vial. Those samples also collect total nitrogen as well. We're also going to be collecting 2 types of fluorescent samples. Samples in a large 40 ml clear vial, and also a smaller set of samples in these small amber vials. One warning about these small vials is that they can be somewhat delicate, and so you want to be really careful when you're opening them, closing them. I've broken 1 or 2 of them when I grip too tightly, so be aware of that. We're going to collect samples also for volatile organic carbon, and finally we're going to be looking for the presence of hydrogen sulfide gas in the tap water. Now, one thing to remember is that when you're out in the community collecting these samples, don't feel like you need to explain what each of these is, or what they do, or how they're analyzed. You know, if you get questions, you can just say, that's a great question. I'm a volunteer, not a chemist, but I can give you the contact for the person who can give that information, who can explain to you what the samples actually do. Your job there is to collect the samples that we're going to use to screen for the presence of contaminants in the tap water. Okay, so now you're ready to start sampling. You are in the location, you're in the home, and the first thing you need to do is find an appropriate source of tap water. What you're looking for is an accessible faucet that does not have an aerator. And an aerator is the thing that you often find on your kitchen tap that makes the water look sort of foamy. You know, when you turn on, like if you have water just coming out of a hose, it looks clear. When the water comes out of your kitchen tap, it looks sort of white and filmy and milky. That's because there are air bubbles added to the water. So if the only taps that are present in the home have aerators, you're going to need to ask the person living there if you can remove the aerator. Usually they just unscrew. You can unscrew them. It might be easier to find a sink or faucet that doesn't have an aerator. Laundry basin sinks, bathtubs are great choices here. I sometimes get a little nervous about asking people if I can alter parts of their house when I'm out collecting samples, so it might be easier to use a bathtub or a laundry sink. If you're not sure if there's an aerator, one thing you can do is just look into the sink. If it's sort of clear and it's like you could put your finger or a chopstick or something up it, there's no aerator. If you see sort of a metal mesh, there's an aerator. Okay, so now I've found a sink that does not have an aerator and I'm ready to start sampling. The first thing to do is make sure that you have everything you need. So make sure that you have vials for all of the samples that you're collecting. In this case, we have 5 vials, we're collecting 5 samples. Make sure that the vials are all labeled and with the correct sample number. So here, for example, this is vial NPOC, non-purgeable organic carbon, sample 434. The reason that this is important is because the only way we have of tracking these samples is the sample number. This also provides a measure of anonymity to the homeowner, to the person living in the home. The only number that the analysts in the lab see, the only number that gets reported to our databases is this number. And so that is a way that the person who lives in that home can be sure that we're keeping their identity as anonymous as we can. So make sure that you have the same number on each of the different vials that you're going to be sampling. Also make sure that in addition to your 5 vials, you have a sample collection sheet. On the sample collection sheet should be the sample number, and you also should have information about the general neighborhood location, the address, a contact name, and contact phone number or email for the person in the home who you've been talking to. That way we can get them information about their water. If there's a space to put down notes, for example, if you had to sample, if you had to take off an aerator, or if there's some other thing, if you smell something when the water turns on. It's a good place to record these things. So there's a sheet that keeps track of the samples. This is the only way that we can link the sample to the house, so the address needs to be on the sheet. But you can assure the homeowner that this address and my personal computer are the places where those addresses get stored. We also have a chain of custody form, and this chain of custody form is important. It keeps track of who had access to the samples when, so you'll also fill this out when you're collecting. Okay, so let's run through all the things you're going to need when you start collecting your samples. You'll need your vials that are labeled with the number, a pair of gloves, your sampling record sheet, your chain of custody sheet, a copy of our instructions, a pen, also concentrated hydrochloric acid in a dropper bottle, hydrochloric acid that's been diluted 1:1, a pipetter with tips, a forceps, lead acetate paper, a cooler to store your samples. Okay, so here I am, I'm ready to sample this particular tap. I have all of my supplies laid out. Obviously, it may be more or less difficult to lay all your supplies out depending on where you're working. But what you're going to do is you're going to get prepared to sample. So the first thing to do is you're going to turn on the tap and you're going to let it run for about 10 seconds. While you're doing this, observe the water. Is there a discoloration? Is there a particular smell that you notice? If the homeowner tells you or the renter tells you that they've seen sheens on the water, that they have smells, write that down. Right? That's good information for us to have. Okay, I'm going to turn on the water and I'm going to let it run for 10 seconds. Now I'm going to reduce the flow down to about the width of a pencil. So you want a steady flow. You don't want it to sort of be sputtering, but you definitely want it to be lower flow. And this is important because part of what we're trying to do here is minimize bubbles. Now, bubbles are the enemy of many of the analyses that we're going to be doing. If you have ever poured yourself a beer from a keg, or if you've ever poured a soda out of a can into a glass, you know that if you hold the glass straight up and you just dump the liquid in, you're going to get a lot of bubbles and a lot of fizz. To minimize bubbles, you want to tilt the glass to the side and gently pour so that the liquid sort of flows down the side of the glass and rises slowly and you don't get a lot of bubbles. That's what we're going for here. Okay. The first sample that we're going to do is a non-purgeable organic carbon sample. This is just the order I do them in. So what I'm going to do is I'm going to unscrew it. I'm going to tilt it to the side, and I'm going to fill it most of the way. I'm going to cap it. I'm going to shake it to rinse. I'm going to discard the water, fill it part way, shake it to rinse, discard, fill part way, shake to rinse, discard. Now I'm going to fill it with the sample. You want to fill it to the shoulder of the bottle, the place where the bottle sort of heads inward toward these threads. So I'm going to fill it slowly. Then I actually went a little bit over. So I'm going to carefully decant a little bit. Now I'm going to add 3 drops of this concentrated hydrochloric acid. 1, 2, 3. This is concentrated acid. It may fume a little bit. You don't want to get it on you. I'm going to close this. I'm going to invert it to mix it. And I'm going to put it into our cooler. The next samples I'm going to take are for fluorescence. I'm going to start with this large clear vial. We're going to follow basically the same procedure. Triple rinse and then fill, except this one is getting filled all the way to the top. We want to have no air bubbles in here. And I'll show you a little trick for how to do that when we get to that step. So once again, filling it at an angle, rinsing, discard, fill, rinse, discard, fill, rinse, discard. Now again, I'm going to try to fill it all the way to the top without overflowing it. So we're going to fill it all the way to the top. Now, the top of this, the meniscus, is a little bit bowed in. That might leave a bit of an air bubble. So one trick you can do is you can take the cap, put a little bit of liquid in the cap, gently pour it into the top until the meniscus, the layer of water at the top, is sort of like an upside down bowl. Then we put on the top, close it up, and then when we turn it upside down, we can check for the presence of an air bubble, and there is none. So this is a success. This is a good sample. We can put this also into the cooler, and we can move on to the next fluorescent sample. Then the next fluorescent sample is in these small amber vials. I said this before, but it bears repeating. These vials are a little more fragile than others, so you want to handle them very gently. Once again, we're going to triple rinse them. And because they're so small, the water sort of sticks to the inside of them. It can be hard to pour it out, so you may have to give them a little bit of a shake to get the water out. And then we're going to fill, once again, we're going to fill all the way to the surface, all the way to the top. We're going to add a little bit of water to the top to make that nice bubble at the top. And then we're going to cap them. We're going to close them. Again, this is the point where you don't want to squeeze the bottle too hard. Very gentle on the bottle, pressure on the cap. It's okay if a little bit spills out over the top, that's totally fine, but we don't want an air bubble, and there's no air bubble in here, so we're doing good. Okay, the next two are a little tricky. The next one we're going to do are the VOC, volatile organic carbon. Now this is a little bit different because it already has something in it, so we're not going to be rinsing it. There's 25 milligrams of ascorbic acid, basically vitamin C at the bottom of this. If we were to rinse it, we'd lose that vitamin C, so we don't want to do that. What we need to do is we're going to gently fill it up to about the top. Don't let it overflow and don't spill it. Okay. Okay, so there we go. I filled it up to the top. I'm going to cap it, and I'm going to let it sit for a minute. While I'm waiting, I'm going to get my pipette, make sure it's set to 250 microliters. It should be preset. I'm going to put a tip on it. I'm going to get ready to add the acid. Now, remember that the way to use these is that you push, to fill it, you're going to push all the way down. To suck up the liquid, you're going to let your thumb come back up slowly and smoothly. And then to put the liquid into the new container, you're going to push down slightly past the first stop. Okay, so it's been about a minute for this one. I'm going to invert it a couple of times to mix that ascorbic acid into the tap water sample. I'm now going to uncap it. I'm going to take this vial of 1:1 diluted hydrochloric acid. Take the pipette, put the tip of the pipette into the acid. I'm going to push this blue button down to the first stop. I'm going to slowly release my thumb so that I fill the pipette up with the acid. Then I'm going to place the tip into the sample, and I'm going to push my thumb down just past the first stop. And I put the acid into the sample. Now, we don't have that nice convex bubble shape over the top. So what I'm going to do is I'm going to add a couple more drops of sample to get that nice convex shape where it's bubbled up over at the top. I'm going to close the sample down. I'm going to turn it upside down to check for air bubbles, and I don't have one. For this particular one, if there's a tiny air bubble, it's probably okay. We're going to try to minimize them, but if there's a very small air bubble, that's fine. I'm going to put this into the cooler likewise, and I'm going to address the final sample that we're going to take, which is for hydrogen sulfide gas. For this one, what we're going to do is you're going to do a quick triple rinse. Then you're going to fill the vial basically up to about where the threads start. The threads are the screw top parts here at the top of the vial. Then you're going to take your forceps and you're going to count out 10 pieces of lead acetate test paper. This lead acetate paper, it's a little tricky to get out. I've pre-counted 10 here. It's important to remember that water that has been exposed to lead acetate paper has become a waste product, and you need to return it to Leeward Community College or to the lab at UH Manoa. So I've got my 10 test strips here, and I'm going to dunk them into the vial about 15 to 20 times. Okay. Then I'm going to cap it. I'm going to mix it. And if it turns any particular color, take a picture of it against a white background and send me the picture. At this point, we've collected all the samples. These lead acetate papers should go into a container for waste disposal. The acetate contaminated tap water should also be preserved to bring back to Leeward for proper disposal. And at this point, you've collected your sample. You can thank the person who let you sample their water, close up your cooler, and move on to the next house on your list, or return back to Leeward to drop off samples. Thank you for your attention. Please let me know if you have any questions.